Welcome to one of the later episodes in our little Rust class here. Now, I know that this is just getting you started into Rust, and there's so much more to cover. What we did last time was we built something that made a blocking request, but a lot of you want to know how to do threading, and today is a simple way to do threading. I want you to be able to use libraries that use threading. I want you to be able to use async and await. This is not a deep dive in how to write system threads or communication between different threads or whatnot. This is an async and await primer. This is going to get you using async and await, which is going to let you use a bunch of different libraries that already support it. So let's jump into that. This is the code that we had. What we're going to do is we're going to add a library called Tokyo. Tokyo is one of the main ones. Now, there are other ones like Rayon, which provide support for heavy parallelization of computation. Tokyo is not really in the big computation heavy. It focuses more on I/O intensive tasks. So it's the much more common between the two threading libraries. Tokyo is an executor library. Basically, it makes an executor that allows you to execute await things that need to be awaited on a thread, on some thread. It doesn't really matter. It's just a work processing queue effectively. Now, we want to be able to use the non-blocking. All right, we want to be able to use the non-blocking. So I can type out the non-blocking right here. We're just going to say res equal request get args.url. And this works. So this is the non-blocking. We don't have to include the feature for blocking like we did last time. But if you look here, if you look at what res is, it's a future. This is very important because a future doesn't do any work. A future is nothing. Nothing happens. With this code will run and you'll have a future and nothing happens. You must await a future. So if you ever see a function like this that returns a future, so this is giving us this future of output, you have to await it or nothing is going to get done. So we could do await right here, just like this. You're going to get this really helpful message that says suspend execution until the result of the future is ready. So basically this is saying we want to suspend execution of this function here until this is the whatever we're waiting on has finished. Pretty cool. So you'll get this really helpful error that says await is only allowed inside async function and blocks, which means that this doesn't meet this criteria. Our main is not async. So we could make this async just like this, but now we get another error. You'll notice that this doesn't actually complain about await anymore. But what does happen is that we can't make main an async function because main is actually how the OS enters the application, and this cannot be, it's not allowed to be asynchronous. There's no executor to put this function on. If you guys want, we can go into how an executor like Tokyo works, but basically, again, it's a work queue, but we haven't built a work queue to put this function on. Tokyo comes to the rescue and actually makes this really easy. So let's add Tokyo. So all we have to do is add Tokyo like this, which we're using version 1.32, and we're doing all the features. One problem that people have talked about coming up is the fact that there's a lot of features in Tokyo, and sometimes it's confusing as to which ones. Sometimes the errors you get are because you haven't enabled a feature. I highly recommend if you're just starting using Tokyo, you use all the features, you just do the features full. If you're wondering what features a crate has, let me show you a cool little thing. So if you go to Tokyo on crates.io, you'll be able to go to its documentation here, docs.rs. And up here in docs.rs at the top, this is something I didn't know until like a week or two ago, there's the feature flags. And here are all of the features. So you can see that this is the full, and we're including this, but there's a bunch of other features that you can. So that's pretty awesome and pretty fantastic. So if you're wanting to know what Crates a Feature has, go check it out on docs.rs. All right, back to the code. We have our Tokyo now. Let's do this. Now this, we're gonna cheat. Tokyo made, I know, you guys love them. We made another macro. Tokyo made a macro that makes this really easy. So basically what we can do is just declare the Tokyo macro. So we'll do Tokyo main. We can delete this now. This is the old way of doing it. And you can see this now works. Now, what does this Tokyo macro do? Well, the basic thing is it basically makes a new main function. And then in that main function, it makes an executor. It makes all of the different code that you need. And then it puts this function, this main function, onto that executor as an awaitable task. So then everything that's returned in here as an await is already on that parent executor. So all the work done in this main function is handled by that executor, that await block. This is really cool. This is awesome, and it makes it really easy. Now again, I don't want to go into everything that happens here, everything that's going to be dealt with here. If you'd like to understand how Tokyo main works more, if you'd like a deep dive into that, if you'd like an investigation into that, I'm happy to do that. Let me know in the comments. I'm trying to make it so that you can use async and await. Now let's check this out. We've got this, it's all working, and we now have a result. This is pretty cool. We're just going to unwrap this like we've been doing with the question mark, and so we don't have a result anymore, we actually have a response. And if you remember, we need to get the text from the response, so we'll do .text here. We're just going to chain it all in one place like this, and let's see what we have now. We have another future. That's okay, it doesn't even matter. Check this out. We just await this, and now we have another result. So we're going to put another question mark on there, and we're done. This is it now. We now have the text, and we can print this out right here as we have been. So now we're using asynchronous code that's using awaits, and it is, in this case, the default Tokyo is multi-threaded. Async and await does not mean multi-threaded. It means that it's breaking up. It could all be on one single thread, just to make sure that we understand what async and await does is it's breaking your work into chunks that are awaitable, which means that other work on that same thread could happen while you're waiting for that work to be done. Now, that work could also happen on other threads as well. You don't know. You know, I've said this is how Tokyo main does this, but do you guys want to do it without Tokyo main, without this, just to understand maybe what it would be doing? Let's do that, because you know what? While macros are fantastic, it's always good to understand how they work. Without Tokyo main, we can't have await, and that's a problem. So let's fix that. What we're going to do is inside of our main function, since we can't have async in main, we need to create a executor, and for that we're still going to use Tokyo. We're going to use the Tokyo executor. We're going to do let mute runtime equals Tokyo runtime new, and you're gonna have to forgive me. We're just going to unwrap this. If it wants to fail, let it fail. Happy to. You could actually handle this. Like I said, this is not exactly what it does. We're just doing it. So we made a runtime. This is something that's going to take some threads. You could configure it with how many threads are in the pool for the executor, from 1 to how many ever cores that you have. And now what we need to do is wrap all of this code into basically something that runs on that runtime, and then you can await it. So what we can do is runtime dot block on. And then, see, this is asking for a future, and we'll give it one. This is like the parent level future, and we're going to put all of this into that future. There's also one other problem. We can't use the question mark operator in here. Why? Because we're not actually returning anything from this asynchronous thing here. So we could actually move this out to our own function. So, you know, we could make a function out here, function run, that now returns a result. And now you'll notice this is complaining that this function isn't async. So we'll make this async. So we'll say async. And now we've encapsulated the running of our main function. And we could really remove this error from our main function just like this. And we'll remove this okay. And now what we can do is we can delete all of this and we can call run. Now you'll notice this is async. And when a function is marked async, what happens? Well, it means that run actually returns a awaitable thing, a future. Oh, so that means we have to await it. So we have effectively done this. All right, so we have effectively done what that Tokyo main macro was doing. We took our main function, put it in an asynchronous function. We called await on it inside of the runtime. So now the runtime is going to run this and execute it. Let's actually run it. Don't take my word for it. Let's actually run this and make sure that it actually is still working. Cargo run, and we need to pass a URL. So we'll do https google.com. Now, Cargo's going and getting the stuff for us. It's compiling all the stuff. And we got google.com. It's not a great thing to get like this, but this is google.com if you wanted the HTML for it. There, you've got it. So it's running, it's working, and this is all pretty fantastic. Now, this is a really, really light introduction into async and await. Remember, if the function starts with async, it means that it doesn't return this result. I want to be very clear with that. I think that's a problem people struggle with. If you mark this as async, this is actually syntactical sugar to wrap this in a future. So if we don't call await here, what type is this going to be? This is going to be a future of a result and error. It's going to be a future. Remember, an asynchronous function is going to return a future. If you look at this get function, it looks like it returns a result of a response, a request result with a response. But remember, it has async on here, which means it's returning a future. And what do we know about futures? Futures don't do anything unless you await them. Futures will not do anything unless they're awaited on an executor, which means you have to be either inside of an async function already, that's already on an executor, or you have to start your own runtime. Now, obviously, this is a really simple solution, but I wanted to show you so that you had the understanding. Now you can use any of those libraries out there that have async and await. Now, there are very specific contexts around. Remember, basically, we await here. It doesn't mean that it's the same thread over here. This part right here doesn't have to run, doesn't have to resume execution on the same thread. That you have to be very careful about, because if you're going to hold a lock, for example, if you want to lock something here and then let go of the lock here, it means you're holding that lock across threads. And either you need to wrap that lock in something that can be cross-threaded or have a lock that supports that, or it means that you need to just not do it. So it does bring in a lot of different stuff. We're not covering all of that because we want to keep this to, little bits of learning and education. And so I think that's a really great place to stop for this. Now, what I want you to do is I want you to leave me a comment with what you want to learn about, what your biggest burning questions are, so that I can make sure to make content on that. We're getting really, really close to the place where we start doing deep dives and we start building applications with Rust. Thank you so much for watching, supporting.